Let's talk about how to graph piecewise functions. In a moment we'll look at how to graph this function on the calculator, but first let's just talk about what the graph should look like from the formula here. A piecewise function defines the function. It defines the function using different formulas for different values from the domain. And so there are really four parts to this expression that we need to kind of keep track of. There's the formula for x values that are less than 2. There's the formula for x values that are bigger than 2. And so each of those represents a different part. And we can think of these as being sort of logical statements that are either true or false. And when they're true, they tell us to use the mathematical expression that applies. So it's important that the piecewise definition doesn't have these logical statements overlapping. Values that are less than 2, when that statement is true, the other statement can never be true. It will always have to be false. Okay, well, with that in mind, we're defining the function by the expression x squared when x is less than 2. And so a graph, for any value less than 2, the graph is going to look like the parabola x squared. Exactly at 2, this is a strict inequality, so exactly at 2 we're actually going to use the other formula. So I'm going to put an open dot there to represent that the function isn't defined there at 2, but I can get as close to 2 as I'd like. So if I wanted to figure out the value of the function at 1.9 or 1.99, I can get as close to that open dot as I'd like. For anything bigger than or equal to 2, I'm going to use the expression 9 minus x to graph the function. And so at 2, 9 minus x is 7. I should say that at 2, x squared, of course, is 4. And so the other piece of the function takes over at 2 comma 7. The x value 2 gives me a height of 7, and then the line has a slope of negative 1. And so the rest of the graph would look something like that. Now, with a TI-83 or a TI-84, we can graph piecewise functions by using the test command to define the logical statements. And it will work in the following way. What I'd like to do is enter the expression. I'm going to open up parentheses, enter the expression x squared. That is true when x is less than 2. And so I'm going to put those two pieces together essentially through multiplication. I'm going to open up a second set of parentheses and go to the test menu. Oh, sorry, actually first let me enter x, our variable, and then I'll go to the test menu to enter the logical test less than, which is option 5, and so we can enter that logical expression x is less than 2. So this will evaluate to equal 1 if the statement is true and 0 if the statement is false. And so we can add the second piece. Again, in parentheses, I'm going to enter the expression 9 minus x, and then multiply by the logical statement x is, going to the test menu again, it's a yellow menu, so I hit second, and then the math key takes me to the test menu, and I want greater than or equal to, which is option 4, hitting enter to select that option, greater than or equal to 2. So to explain a little bit what happens with this expression, the calculator is going to evaluate the logical expressions to be 1 if the expression is true, and it'll equal 0 if the expression is false. So when x is in fact less than 2, this other expression will be false, and that part of the calculation will be equal to 0. And when x is greater than 2, then the x less than 2 is going to be false, and so that part of the expression would evaluate to equal 0. And so then going to the graph screen, the graph is set to standard position. We see the parabola and then the line. Now there is one sort of uncomfortable, awkward thing that the calculator is doing here. There shouldn't be a connection between those two, but the calculator is kind of creating one. And so to get rid of that, if we go to the mode menu, we can change to dot mode rather than connected mode. And now the graph is not going to make that connection, but the parabola looks a little strange because it's not making any of the connections between dots. What's really nice about entering these piecewise expressions, or one thing that's nice about entering these piecewise expressions into the calculator, is that if we go over to the table, I can then evaluate the expression 1.9, 1.99. So this is evaluating the expression using the square command. Once I get to 2, it's going to switch and evaluate the expression using the appropriate formula, 9 minus x. And so we can use the table with the piecewise function, and the logic commands direct the calculator to use the right piece at the right time. I should mention that my table is set so that the independent variable is in the ask mode. If that was set to auto, the table would fill automatically, but still in a similar way, it would fill automatically according to to what it should be. So x squared at 0 is 0, at 1, 1 squared is 1, and then once we get up to 2, we go to the other expression. So we get 9 minus 2 is 7, 9 minus 3 is 6, and so on. Thanks for watching.